Hello everyone and welcome to another video for Elephant VFX Patreon. Today we're going to be looking into skin look development, human skin look development, or look dev for realistic human characters, I would say. So we have a lot of things to cover and I want to explain hopefully the entire process from manipulating the original source material that we're going to be using for texturing to the final render. So let me quickly explain to you what I'm planning to do today. So let me show you like a quick render here. So hopefully this is what we're going to achieve today. So and it is a little bit tricky for me because I have two monitors here, and then I have my laptop as well. And for whatever reason, I mean, not for whatever reason, I know why, but these images look different in all my monitors, and the laptop, they look completely different. I'm looking at this image in, on my good monitor, and they look fine. I don't know how it looks to you, but it's a little bit tricky with the skin shader because it's very volatile in the sense that when you get a little bit more redness or a little bit more contrast, it looks completely different. So it looks very different in all my monitors, but in this one, which is the monitor that I'm using for look dev and for rendering, here it looks very good to me. Again, I don't know how this will look to you. But also because I'm using the capturing card, the Elgato card, which also shifts the colors a little bit and the contrast. So I'm not sure, but you have this image in the project files anyway, so you can take a look at that one. And if you have a good monitor, hopefully it will look good. Anyway, this is what we're trying to achieve today. And as you can see here, this is what I consider a realistic skin look dev, a realistic skin shader. It looks pretty good to me. I spend quite a lot of time balancing all the different channels of the shader, all the different displacement maps and whatnot. And I consider this very successful. And as you can see here, this is just skin look dev, right? So I chose to close the eyes of this character because I'm not going to be dealing with eyes in this video. We can probably make a different video only about eyes, texturing, and look dev. And most likely I will do that at some point because I think that's interesting, especially if you work with digital doubles. And also there is no groom here, although I added a little bit of pitch fast that you can see in some areas. It's subtle, but you can see it in some places. And this is all rendered with Houdini, Solaris, and Karma. All right, this is Karma. I have to say that I'm not a huge fan of the skin shader or the subsurface shader in Karma using Material X. I don't like it very much. I rather prefer to use Arnold subsurface scattering with a random walk to shader and the RenderMan shader as well. I think those look much better, and it's probably easier to achieve a realistic look than using Material X and Karma. But as I said many times, I want to force myself to use Karma as much as possible because I don't want to rely on third-party renders, especially when I work at home, because that means extra licenses and extra headaches that I don't want to deal with. In production, I said this many times, I never use Karma in the studios where I worked in the past. I never had to deal with Karma for production rendering, but I want to push it as far as I can because ideally I want to work with Karma in production because again, I don't need to worry about extra licenses. All right. Anyway, what I'm going to explain today is completely software agnostic. So you should be able to achieve the same results using any other 3D software and any other render engine. And hopefully, if you're using RenderMan or Arnold, you will get even better results. All right. I don't know about other renderers. I think V-Ray also has a really good subsurface scattering shader. I haven't used that in many years. I've used V-Ray only in one production in my life. So I'm not very familiar with the stage of that. I don't know about cycles and Blender. Probably you can get similar results to this as well. But again, we're gonna focus 100% on Solaris, Houdini Solaris and Karma today. All right, so yeah, this is the end result, and this is hopefully what we're gonna get. I have a render here just with the displacement maps, and they have been very well balanced in order to get the detail that I want. So yeah, this is the goal. All right, so let me explain to you what we're trying to do today here, or what I'm planning to cover, because it's actually quite a quite a few things that I want to cover. So let me just get a notepad here so I can type quickly. So we're going to rely heavily today on V-faces. If you're not familiar with V-faces, if you go to Texturing XYZ, in this website, you have what I consider the best commercial texturing resources that you can find online. Obviously, if you work on high-end productions, you might have similar data or even better data to work on your digital doubles. But obviously, if you are a solo artist or a freelancer and you don't have access to all that fancy material, this is the best you can hope for, or at least it's the best that I could find. If you know other resources online, please let me know. So here you have multiple things that you can use for creating your characters. But if you go to B-faces here, you have a library of characters, and it's pretty big. So you have characters with different ages. So you have people in their 20s and 40s and 60s and even 80s. You have white skin, you have black skin. I think you have other races as well. But if you go to any of these, let's say we take this character, you know, these are $39 for personal licenses. So that's pretty good. If you want to try all of this at home. Commercial use is like $300, which is also a pretty good price. If you need to do this in a custom shoot, it would be extremely expensive. So this is a very fairly priced. And as you can see here, well, you can see the specifications here, where you can read a little bit of information, but you get a lot of different maps. You get albedos, you get a fully calibrated displacement, you get a multi-channel displacement, you get normal maps, cavities, utilities, ID masks, ZBrush files, geometries, etc. And as you can see, the resolutions of the maps are really good. The important maps are 16K, and then the utility maps are like 8K and 1K. So it's pretty good. This is top-notch material, right? So basically, I want to show you how to get one of these faces and use it in your own character, right? The whole pipeline. So let me type here what I'm planning to cover today. So again, we're going to start with B faces, and I want to show you how to take those B faces into your own geometry. So basically, I'm going to show you a way of wrapping these faces onto your character, right? And by doing that, you should be able to use your own character, your own geometry of character. And it doesn't have to be like a realistic human. It can be, a fantasy character, or it can be whatever, as long as that character is humanoid in one way or another, right? Again, it doesn't have to be realistic, but it has to be humanoid. And by that, I mean, like a head with ears and eyes and nose, etc., right? So I'll show you how to wrap B faces to your geometry, to custom geometry. That will be the first step. Then I will show you how you can transfer B faces textures to your custom geometry, right? That's basically the whole plan. So you can basically extract all the information that comes in the textures, in these textures that I pointed out here, in all this stuff here, how you can transfer all of that to your own custom geometry with custom UVs. Of course, you can have UDIMs, you can have completely different UV mapping than the original face or the original head, and everything will work very well. So for the wrapping, and I think this part I saw you how to do that in other video that I made a while ago. I think I saw you how to do that using a software called Wrap3, which is which is an industry standard. I mean, all the studios use Wrap3, and I believe Wrap3 is also available inside of ZBrush. And I think I might be wrong about this, but I think it might be available for Blender as well as a plugin. I don't remember exactly if it's available for Blender or not, but it is definitely available for ZBrush and as a standalone software as well. But in this video, I'm not going to show you how to use Wrap3. Again, if you want to take a look at Wrap3, I have a video that I made a while ago, probably like 2 or 3 years ago, and that is still valid. It still works in the same way that I show you. So, but again, it is an extra license that you need to worry about and something that you need to pay for. So I'm not gonna show you how to do it this time. This time I'm gonna show you how to do it completely in Houdini using Topo Transfer, which is, you know, if you're using Houdini, then you don't need to pay for an extra license. You can do all of this in Houdini. Wrap3 has a lot of options that you can use in your pipeline for many of the things. Houdini doesn't have those things out of the box, even though I believe you could actually build them in Houdini, but Houdini doesn't have as many options as Wrap3. But for this particular task, you are all good with Houdini Topo Transfer, and you don't need to do any custom setup or anything like that. Everything works out of the box, so that is good. Cool. So that's when it comes to the geometry. When it comes to the textures, you can transfer the textures. Made a typo here. You can transfer the textures using different software as well, right? So you could also use Wrap3. And the good thing about Wrap3 is that they created some kind of a preset where essentially you can do all of these with a couple of clicks, which is very convenient. But again, I'm not gonna use Wrap3 today, so I'll show you how to transfer textures also using Houdini, which is great. Because again, you don't have to care about extra licenses, but I will also show you how to do it with Mari. Just because Mari is a standard tool for texturing in the visual effects industry, so I think it is worth it to show it how to use it. It's extremely useful, and I believe you can do it as well with the indie version of Mari or even the free version of Mari, so that's good. But no matter what, I still want to show you how to do it inside of Houdini, so you don't need to worry even about having a Mari license for that. Okay, cool. Then we will take a look at how to create a light rig in Solaris and Karma, so you can match the references. The people from VFace or Texturing XYZ, they are again, they not only provide textures and geometry, but they also provide HDRIs that work very well. They are they have a really good high dynamic range, and they are very well balanced. So it's very easy to create a really good light rig for look deving your characters. So we're gonna look into that as well. Then we're gonna take a look at how to work with the displacement maps. And here we're going to take a look at different things. So first of all, Texturing XYZ, they provide a calibrated displacement, or what they consider to be a calibrated displacement. And that's very easy to use. It's just one single displacement map that you connect to your shader and you're good to go. So I'll show you how to use that one. But then they also provide a multi-channel displacement. Right? And the good thing about the multi-channel displacement is that they store different frequencies, different details of the displacement map in different channels of the EXR texture. So then you can mix, you know, the green channel, the red channel, and the blue channel to get different effects, right? So that is very important, and I will show you how you can use that multi-channel displacement. And by the way, this doesn't relate only to V faces. If you have ever worked in a big visual effects studio, this is the way that we have been creating digital doubles for, I don't know, since I can remember, right? I think I worked on my first digital double like 15 years ago or something. And we were already making them in this way, right? So the people from B Faces, they kind of replicated the way that we used to work in Visual Effects Studios, which is great. All right, then we're gonna take it one step further, and we're gonna be using this multi-channel displacement as well, but we're gonna be combining that with isolation masks that are also provided by B Faces. And again, this is a very common practice. We used to make isolation masks for all characters, really, not just for digital doubles. So this will give you extra control, because then you can use your multi-channel displacement, but you can control it per area, meaning that you can have more wrinkles or less skin pores or whatever details, depending on what area of the face you are focusing on. Like maybe you want to have more wrinkles on the actual, let's say, the forehead of the character, but you don't want to have that many wrinkles around the eyes, right? So thanks to isolation masks, you can control all of that independently, which again gives you a lot of control, and you can make a better looking digital doubles. All right, cool. Then when it comes to displacement as well, I will show you how you can add extra details that are not part of the B Faces, right? So let's say you have a character, it looks great, but then all of a sudden you want to add, let's say, like scar, or something like that in the face. How can you do that and combine that with the rest of the displacement information? I will show you how to do that as well. All right. Then we're going to take a look at roughness and how you can control the roughness. And we're going to do this based on the ISO masks as well, right? Because again, you might want to have a part of the skin that is a little bit more oily or a little bit more shiny, a little bit more rough. So that's very easy to control once you have isolation masks as well. And this is not something that I do all the time, but we can take a look as well as how to control the specular a little bit further. Generally speaking, specular and roughness is kind of like an illusion, meaning that all that information should come from the displacement map, right? And if you have a very well balanced displacement map, you will get roughness and specular for free. But sometimes you want to have that extra artistic control, even if it's not physically realistic, you still want to have extra control. And again, computer graphics, when it comes to film and television, is not about physically correct. It is about what it looks good, right? So that's what I want to show you, how to control roughness and specular in a more artistic way. All right, cool. Once we're done with all of that, we're going to jump into the actual subsurface scattering shader, and we're going to explain a little bit how the SSS works in Karma and how you can balance the albedo map in order to get like a proper skin color. All right, we're gonna do that. That's actually pretty. I'm leaving this for the very end, because this is the easiest part. Right? Doing all of this is a little bit more complicated and a little bit more technical. Once we're done with that, I will show you also how to create custom AOBs for Nuke, which is also something very common. And by that, I mean giving the compositors extra AOBs so they can push the look even further if needed, right? The problem with skin shader is that, as I was saying before, it's very volatile in the sense that, let's say you have a shot and that shot is like 3 seconds long. Maybe the skin looks great in the first 2 seconds, and then, 12 frames later, after those first 2 seconds, it looks a little bit weird because, whatever the lighting is doing, or maybe the character gets in shadow and then it doesn't look as good. So having those extra custom AOBs for Nuke, it will help the compositors to fix those issues. And for custom AOBs, I mean, the very well-known AOVs like diffuse component or light groups or SSS component or specular component or whatever, but also extra AOVs like regions of the face, so they can isolate in Nuke and they can control how much SSS they have or how much shyness they have, or if they want to project some details on top. So I'm gonna show you how to do that in Solaris and Karma. And that's pretty much it. And well, I mean, then we will do like a final render and then we're good to go. All right, so it's a lot of things to cover, and hopefully this will set you in the right path in order to create realistic digital doubles. The only thing that we're going to be missing here, if we were creating like a proper digital double, it would be the eyes, which again that will be a video on its own, because it takes a while. Eyes are a very complex subject to texture and look dev. So again, probably we will do this in a future video. And obviously another thing that we're missing, it would be hair. And as you know, I'm doing a series on hair and grooming in Houdini. So maybe we can use this same character for that future video. We can use this same character in a future video in order to create the hair and from scratch, like creating the grooming and everything, and then do the look dev as well. All right. So yeah, this is the plan. A lot of things to cover. So let's do it. Let's jump into it and let's get this done. So let's start by looking into the texturing XYZ B-Face. So once you download one of those packages, it comes with, it is this folder here. So it has a folder called Head, References, and Extra. So if we go to Head, we have geometries, and here we have the head with the eyes open and the eyes closed. So depending on what you're doing, you want to use one or the other. Generally speaking, I would say you're going to be using the open eyes because, again, generally speaking, when you're creating your own character, you would model that character with the eyes open. So most likely this is the geometry that you're going to be using. We're going to take a look at that in a minute. Well, actually, let's take a look at that now. So this is the actual head that came with the B-Face package. So if I go inside, you can see it has a very clean topology. Everything works fine. And if we take a look at the UVs, these are the UVs. So, they are using one UDIM. The textures provided with this package, they are 16K. So it works, it works very, very well. All right. So this is the geometry. And again, if I choose here the closed eyes, well, it is essentially this, but it is the same UV mapping. But in our case, we're going to use the open eyes to transfer all the details to our own character. All right, good. Then if we go to maps, excuse me, here we have an albedo. So we can take a look in Nuke. So this is the albedo. As you can see, 16K. So if I zoom here 1:1, we have plenty of detail everywhere, right? Which is pretty good. Let's keep looking into the material. Then we have a cavity map. So the cavity map is a single channel map. So if I isolate the right channel, this is what we get. And this one is actually useful to have an artistic control over the specular, because we can use this to actually mute the specular a little bit in the cavities. So I'll show you how to use this later. Then we have a calibrated displacement. And the calibrated displacement, it is a single channel map where all the frequencies of the skin are combined. I'll show you how to use this map, but we're not really going to use this for final rendering because we want to have more control. So we want to calibrate our own displacement map. So if I go back to my maps folder, here we actually have something called multi-channel displacement, and this is what we're going to be using. So the multi-channel displacement, it's a three-channel map. So if we take a look at the red channel, this is what we get. If we take a look at the green channel, we get different frequencies, and blue channel, we get different frequencies. It's a little bit hard to see, but the detail should be there. And when we take a look at all the combined channels, we get all of these three channels combined. But again, we're going to separate these in Houdini, and we're going to control each channel individually. Then we have a normal map. The normal map, well, it is a normal map, and we are not going to use a normal map, right? This is visual effects, and in visual effects, it's very strange to use normal maps, in my opinion. We usually tend to use displacement maps or bumps, but this is just a normal map based on this displacement, so you can use it. Or if you're using a real-time renderer, you can use the normal map. We're not going to be using normal maps. And finally, we have a utility map, and this is also an RGB map. So in the red channel, we have some information. In the green channel, we have some other information. And in the blue channel, you can have a cavity mask. I think we're going to be using only the cavity mask. We could use these other channels for, tweaking the shader in other artistic ways if we wanted to. I don't find this necessary, but you could use this if you wanted to, right? But yeah, we will take a look at that later. And finally, we have the ID masks, right? So if I drag and drop the ID masks here, what we get is isolation masks. So basically here we're isolating the forehead in the red channel, we're isolating the nose in the green channel, and the cheeks on the blue channel. So I can isolate these ones, and I can use these as masks for controlling the subsurface scattering, for controlling the roughness, for controlling the displacement, and I can use these for custom AOVs later as well, right? So as you can see, we have different areas, so we can have full control over the head. So once we combine all of these isolation masks with all these other maps, we can have a really, really good control over what we're doing, all right? All right, cool. So that is the material that is coming from this package, okay? So if I go back to Houdini, I have imported here this geometry. That again, this is the geometry that is coming from texturing XYZ, and again, the UVs match these textures that we have here. So if we apply any of these textures, everything will look just fine, right? Cool. And then here, I have my own character, right? And my own character, as you can see, is completely different anatomy, and also completely different topology. And this one also have completely different UVs, right? In this case, I only have one UDIM because I just want to make this as quick as possible for a demo. It's just a demo, right? But generally speaking, if you're doing a hero character for the movie, just the head would have probably a few UDIMs, like 3 or 4 or 5 UDIMs. It depends on what you're doing. But what I'm trying to say is, like, it doesn't really matter if your own character has completely different anatomy, completely different topology, and completely different UVs compared with the B phase, right? So these two are completely different, as you can tell. Geometry, topology, and UVs. And again, in this case, my character, my own character, is also a realistic human, but it doesn't have to, right? It could be a zombie. Actually, I've done this with a zombie that doesn't have a nose, or even if it only has one eye, you can do that as well. Then, of course, you would have to do some cleanup or whatever, but everything will work exactly the same. So as long as it's some kind of a humanoid, it should work, all right? Obviously, you cannot pretend to transfer details from a human face to a horse, right? That would never work. All right. So what we need to do is we need to take this face, or this head that came from B face, and we need to wrap it around this face. So essentially, we get this exact shape right? This human here, but we using this face. Because once we do that, we're gonna have this face with this shape, but with original UVs, right? And then with those original UVs, we can use all of these textures, right? Cool. Once we have that, we're gonna transfer from this face converted into that face to this original face with different UV mapping. So we have these textures with this UV mapping. So then we can use it in our custom head. That is essentially the workflow, right? So how do we do that in Houdini? In Houdini, we have a tool called Topo Transfer. And again, this is not a 100% replacement of the software RAP3. RAP3 is an amazing software. It can do a lot of things, especially when it comes to 4D scanning, and it's a marvelous software. It can do a lot of great things. Topo Transfer cannot do all those things, but this one in particular, it can do it, and it does it very well. So again, I don't want to show you how to use RAP3 for this specific task. Again, if you are interested in that, I have a video that I made 2 or 3 years ago about this exact thing. But now we're going to be using Topo Transfer. So Topo Transfer requires a template mesh and a target mesh. So our B face will go to the template mesh, and the target mesh would be our own custom geometry, this one here. So this is going to transfer this into that, all right? So now we need to enable Topo Transfer, press enter in the viewport. And now what we need to do is we need to select common points between the template face and the target face. And we can switch here. You can see here where it says show, template, or target. So we're showing one or the other. And the shortcut to change between those is G. G toggles template and target geometry. So if I press G, I'm gonna target between both of them. Right, so I'm gonna start adding common points. So I usually start with the eyes. So I'm gonna select this point here. And now I go to the other head, to the target, and I need to place this in the same position. So I'm gonna place it over there, right? So now it means that this point in the original mesh is that point in the target mesh. And I'm gonna keep doing that for other features, like here. You don't need a lot of points for this, right? You just need a bunch of points. So I'm gonna be doing that in both eyes. Okay. Obviously, it is easier if the characters are a little bit more similar in terms of features and all of that, but it works very, very well. All right. So I keep adding these. All right, so we have the eyes. I'm gonna go for the nose now. So I'm gonna select like this corner over there. and here you can see how different these characters are, right? So the offset here is a little bit bigger, but hopefully it will work just fine. All right, I'm gonna select the tip of the nose. All right. I'm gonna go for that bit over here. All right, and I'm gonna go to the mouth. So here I'm gonna select that corner of the mouth. Here, that one there. Okay, then probably the top of the lip, which would be somewhere like here, maybe a little bit higher, maybe like that. All right, now the bottom of the lip. All right, something like this. Good. And usually I go for the chin as well. I like to do something like that. All right. And then I'm gonna go for the ears. And for the ears, I'm gonna select this area That was pretty close actually. Maybe this bit over here, that one over there. All right, and maybe the top, which would be something like this, and maybe like this area. All right, I think I'm good with that, and I'm gonna go with the other ear. All right, maybe up here. That one was a huge offset actually. I hope that works well. Okay, good. Maybe I'm going to do like this edge over here. I'll push it over there, and maybe I'll do the same like here. All right. All right, and maybe here in the back. All right, I don't think I want to add anything else. Maybe we can add one here in the back. All right, I think this is enough. I don't think we need more points. So once you're done with your points, just click on solve. And that will start cooking down here. And it's gonna take a little while. Shouldn't take long, right? I mean, it takes like a couple of minutes. Okay, it's done. So yeah, I mean, it worked very well. I think we have a little issue here that we can fix maybe. That's probably the only thing, right? So essentially we went from here to there. And you can see that this and that, they are pretty much the same. But now we're using the original topology that we had there and the original UVs. So if we take a look at the UVs here, these are exactly the same UVs that we had here, right? Which are completely different than our custom character. So now we want to apply the texture maps to this guy and then transfer it to this other guy, right? That's essentially how you will work with this. And again, this is just a live geometry. So if you want to fix that, you can fix that in many ways, right? You can maybe use like a sculpt here, or just use traditional modeling workflows. But maybe here, you want to smooth it a little bit. That's it, right? So I just smooth that, and the problem is fixed. The eyes are pretty good actually, so I don't really want to do anything else. And yeah, I don't have any other artifacts, so I'm pretty good. Cool. Yeah. So now we can transfer the actual textures, right? And how do we transfer the textures? Well, I told you before that I'm going to show you how to do it in Houdini and how to do it in Mari, because it's industry standard, and most likely you're going to do it in Mari. But you can do it here in Houdini very quickly. So we can add a quick material, right? I'm going to connect this one here. And for my base color, I'm going to use this albedo texture that I showed you before. By the way, just to be clear, if I go to my Houdini directory and I go to my textures and my skin, this is the texture that I showed you, Nuke. I just, this one, I just reduced the size to 8K, right? Just because 16K takes just a little while to do things. And again, because this is just a demo, I just want to show you how to do it. I'm not looking for extreme quality here. I just reduced the 16K maps to 8K maps, so we can move a little bit faster. That's it, right? So here I'm going to select my texture, skin, and I'm going to select the 8K version. All right, and once we do that, our texture is working perfectly fine in our custom character. Again, because we're using the same UVs as this character, right? So yeah, this is just working fine. Okay, good. now you can transfer the textures from this temp character to our final character, which is this one with, the UVs that we want to use for our character. And to do that, we can use the labs map baker, right? So in this one, we essentially connect the topo transfer head, which is this one here, to the second input. And we connect our character to the first input. All right, just like that. Okay. If we take a look at this one, now we can essentially control here whatever we want to control. So the output directory, I'm going to select the output directory here. So in my case, I'm gonna go to jobs, texture, and I created here in skin, I created a folder called topo transfer, so we can export it here so we know what we're doing. I'm gonna call this one albedo.exr. Okay. The resolution is obviously whatever resolution you want to use. In our case, we're working with 8K. So, we can just select 8K here. Okay, then what else do we want to bake here? Well, nothing really. If we go to frames, it's just a current frame. Obviously, we don't want to bake any animation or whatever. And what we want to transfer is just a diffuse map, right? We don't want to generate anything. We just want to transfer the diffuse map with a gamma of 1 because we're working with linear space. And that should be everything, right? That should be everything. So now if I click on render, this is going to start to bake all of these. It's 8K, so I would assume this is going to take a few minutes. So I'm going to pause the video, and once this is done, we can take a look at the baked texture. Okay, so the map is done. Let's take a look at that. So here it should be the albedo. Okay, let's take a look, and there you go. And now we have this original texture baked into the new UV map. All right. And as you can see, there are some artifacts in some areas that, well, obviously not everything is going to work perfectly fine. And these are usually occluded areas, right? So if we go to here, yeah, I mean, these are, occluded areas that are very hard to project. So yeah, I don't think Maps Baker is the best tool to do this job, but it's pretty good. I mean, like 95% of the character or even more, it looks just fine, right? It's just some occluded areas that are a little bit tricky and they need to be fixed. And the only way to fix those is with a painting program. And that's what I usually prefer to do the baking of the maps in Mari. Because at the end of the day, if I do it here in Houdini, I'm gonna have to fix those areas in Mari anyway, so I do it inside of Mari. But again, 95% or no, even more, right? Like 98% of the character, it's perfectly fine, right? So I show you how to do this with the albedo, but obviously if you want to do the same with all the other maps, because obviously you need to transfer all the maps, not the albedo, right? Not only the albedo. So you need to transfer, the displacement, the isomask. I mean, all the maps that you're planning to use. The way to do it is exactly the same thing. Just replace the albedo with the other textures, and that's it. You can do multiple at once. Like if you go to quick material, I guess you could transfer a normal, or well, we don't have a roughness, right? The roughness is something we're gonna build, so not really. But I guess you can use the maps in other inputs. It doesn't really matter, right? And then here you can select the diffuse, the normal, the opacity, whatever. You just remember to rename this. So if you connect to the opacity, let's say The displacement map, just rename this one to displacement here, and that's it. Or just do one by one, you know, with a gamma of one, changing the map here, and then just rename this to displacement or whatever. And that's the way to do it. But I'm going to show you how to do it in Mari, because most likely you're going to be using that software more often. So the only thing you need to do is to make sure to export these geometry. So you need to export this one, right? So you can use whatever. This is just a temp geometry, so you can use like a raw FBX output. And let's output this one in jobs, geometry. I created a topo transfer folder here, and I'm gonna call this one custom head topo transfer.fbx, all right, and export that one. And then we need to export our original custom mesh. So let's call this one custom head original. All right, save to disk. And now if I go to my Houdini geometry topo transfer, we have them here. So now we can jump into Mari and transfer all the textures. Okay, so let's take a look at how we can do this in Mari. So I just open Mari. I'm gonna create a new project here just by right clicking and selecting new. And I'm just gonna name this head transfer, something like that. And we need to select the geometry. So I'm gonna go here and let me just copy the path to my project. I'm gonna go to Houdini, geometry, topo transfer, and these are the two geometries that we exported from Houdini. So we need to import both of them. So I'm just gonna start with the custom head topo transfer. So this is the one that has the UVs that are matching the V face. So I'm gonna click OK and create new project. And as you can see, I couldn't care less about the channels because I'm actually going to delete all of them and just start from scratch. So, all right. So here we are. And again, if we go to the UV tab, we can see that these are the UVs that we transfer. It's a little bit hard to see here, so we can just enable wireframe, and you can see these are the P phase UVs. All right, good. So I'm gonna go back to orthographic, press 5 to be looking at the front, and I'm gonna get rid of all these channels here. All right, so I'm gonna go one by one. So first of all, I'm gonna create an albedo map. I'm gonna select my size or my resolution, which is 8K. And if you're not sure about the depth of your textures, you can essentially, let me go back here for a second. This is Nuke. I was prepping the plates for lighting. We can take a look at that later. So I'm going to go to my Houdini texture folder, to my skin, and if we take the albedo map, right, this is the albedo map, we can always use a view metadata, connect it here, and we can see that this is a 32-bit float image, and well, we can see that this is an RGB texture, right? So we just need to use the same in Mari. So I'm gonna set this one to 32-bit, and this shouldn't be scalar because it's a color map. So let's just do that. All right. So now we created this albedo channel, and here you can check that it's 8K and 32-bit float. Now I'm going to import a new layer, and let's import our texture. All right. So we go to Houdini, text, skin, and we can import this texture here. Okay, and it's not showing up, and that is probably because here I'm gonna select, instead of using shader, use current channel. All right, here we have it. And if we take a look at the flat, this is our flat texture. There you go. And everything is looking just fine. All right, so if we compare this one with this one, they look exactly the same. All right. When we created the channel, we set this one as a raw data. If you haven't done that, then your texture wouldn't be in linear space and it would be darker. Don't worry, if you've done that, I mean, you can just redo it again. You can just delete the channel and create it again. Or you could actually just come here, create an sRGB to linear. This is how the texture is going to look like, right? Again, if you didn't enable this raw data, it is going to look like that. No problem, right? Because then you would just get this node here and just click on invert and it will look just fine. Now it looks obviously bad because the original texture is correct. But if that is the case, this is how you can fix it. But we don't need it. Okay, great. So we have the albedo. So now we want the multi-channel displacement. So I'm going to add a channel. I'm going to call this one disp multi. It's going to be a 32-bit float. Let me go back to Nuke for a second. And let me get that texture again. So in this case, it's the displacement multi-channel 8K. All right. So if we connect that one there, same thing, right? This is a 32-bit image and it's an RGB texture. I'm not interested in the calibrated map, right? In this one, I don't really want to use this one, so I'm not going to transfer it. But if you want to use this one, and if we connect the view metadata, here you can see that this is a single channel, right? So it would be different when you create these channels in Mari, it would be slightly different. So for this one, we just do the same. If you want to do the calibrated displacement map, then you would have to click on scalar data. But in this case, because this is an RGB texture, we just do it like this, create a new one, import into layer, select the multi-channel 8K, and import it. All right, and here we have it. And if we check that against Nuke, we can see that it looks exactly the same, right? And if we take a look at this one with no color transformation, there you go. Sorry, my bad. With no color transformation, it looks like that. So if you want to double check that in Mari as well, you can set the color transformation here to none, and it should look the same. All right, good. And now just keep importing all the channels that you need. We also need all the other channels. So for example, the masks, that would be ISO 1. And if I go back to Nuke for a second, well, the normal, we don't care about the normal. So we actually care about the utility. And the utility, as you can see, this is a 16-bit image and also RGB, right? So if we type here utility, and let me check the size. The size is 8K as well. Okay, so 8K in this case is 16-bit and raw data. That is all good. So we keep importing this one, utility. There you go. All right, great. And all right, so this is how it looks in sRGB. and this is how it looks in sRGB, and this is how it looks with no color transformation. So this is all good. So we're just missing the isolation masks, and if we take a quick look at the isolation masks here in Unity, sorry, in Nuke, we can see that these ones are just 1K, and if we check the metadata, these are 16-bit RGB. So same thing, right? In this case, it would be the ISO one is going to be 1K 16-bit raw data. Import, and just select the first one, and there you go. So this is the idea, right? You do this with all the channels that you want to transfer. All right. So let's pretend that I have all of them here already. Obviously, I'm not gonna bother you with importing every single one, but it's just like 3 left, I believe, or 4. No, 3 left. You check that everything is correct, and everything should be correct because these UVs are perfect. Then we need to bring the other geometry that we exported from Houdini. So I'm going to go to Objects, hide this one for a second, and import the original one. Okay. So when we import this one, obviously this one doesn't have any channels. That's fine. And if we show this one again, they should overlap. All right. And this one, if we check the UVs, these should be the custom UVs for our custom model. Good. So with the topo transfer selected, now you can go to Channels, Transfer. And here you can select the source, and the source will be the topo transfer geometry, and the destination would be the original. And now here you can select what channels do you want to transfer. So you can do all of them at once, or you can do one by one, right? Sometimes I find that if I transfer all of them at the same time, Mari sometimes crashes, or it seems to crash. Sometimes actually it doesn't really crash, but it takes a very long time. So what I like to do is just do one by one. Except for example, ISOs. I know ISOs are not going to crash, even if I have 10 of them, because they are lower resolution and whatnot. But just in case, I'm going to select albedo. I'm going to transfer the albedo and click OK. And this is going to take a couple of minutes, and it's going to transfer it. You can see the progress down here, right? On the bottom right corner. It will take a couple of minutes, so I'm going to pause the video and I will continue when it's done. Okay, so it is done. So to check how it actually looks, just hide the topo transfer and select the original. And now if we go to channels, we should have a channel here. So if we select that channel, we should see how it looks. And as you can see, it looks quite cool. And some of the errors that we got in Houdini, we don't have them here. So that tells you that Mari, generally speaking, is a better tool for transferring maps. All right. So yeah, I mean, it looks pretty good everywhere that I can look. Obviously, it's never going to be 100% perfect. Like here, you can see that obviously, you know, these lips are bigger, or they have a little bit more topology. So maybe we need to extend this by just cloning some areas. But, you know, it is the interior of the mouth, so probably we don't even bother about it. But it looks very nice. We can check in the UVs as well. And yeah, here is where we see like the biggest errors, which is expected, by the way, right? Because this geometry shows larger. But this is very easy to fix just by cloning, or even you don't even bother, right? Because maybe you're never going to see this in the character because it's going to be covered with clothing. But yeah, Mari is really, really good for transferring textures, and it is my favorite tool for this task, right? Okay, so now that we transfer the albedo, we just need to transfer the rest of the maps. And again, to do that, just go to transfer and transfer all of them at the same time if you want to, or just one by one, as I showed you before, and you're done. And once you're happy with that, you just need to export the maps. So you can export them in different ways. The easiest way is just to come to this channel, rename it to something like albedo, whatever, and just right click, export flatten, export current channel flatten, and you export it anywhere that you want with whatever naming convention in EXR, right? Alpha channel, disable this, and small textures, disable that. This will prevent you to have issues in some software. I don't know if Karma complains about it, but I know that Renderman used to complain when you have alpha in these maps, so you don't want to do that. The color space, keep it as same as native, which in this case is linear. So, we configure all of that when we imported the channel. So just keep it same as native, and that's it. And just export it, and everything will work just fine. Another way, obviously, would be with the export manager. So you can go to channels, and you can go to export manager, and here, you will get this pop-up with all the channels that you have in your geometry. In our case, it's just albedo. It's picking up the right size, the right color space, the right depth, and the right naming convention. You can do overrides here if you wanted to, change the resolution, change the color space, change the depth, but generally speaking, you don't want to do that. Just select like a place to export them, which in this case it will be here, and just click on export current or export all, and that's it. As simple as that. All right. So this is how you transfer textures in Mari, and now we are ready to work on the lookdev in Houdini. Okay, so now we're in Houdini. I have my head imported here, and as you can see, I've chosen to use the one with the closed eyes, and the reason being is because I don't want to get bothered by the eyes. Right, I told you that we will do probably a different video about hair and eyes. That will take a little while. So I just want to focus on skin in this video. So that's what I'm using the model with the closed eyes. But obviously the same applies to any other character. And if I go inside of this character, there is nothing here, right? I'm just reading the geometry. I'm scaling this down to Houdini's scale, and I'm just moving this up a little bit. So, if I bring a test geometry template body, they are roughly the same size and, in the same location. All right, so that's pretty much everything that we need. I don't think we need to do anything else here in SOPs. So I'm gonna jump into Solaris, and there is nothing here, right? So if I go back to Nuke for a second, and we can get rid of all these textures now. So we have here some references from bphase. So I'm going to be using one of these references for lighting. It came with these references. I think, let me double check here 1 second. So this is the reference that I want to use, not this one. Sorry, my bad. Right, so we're going to be using this as a key reference to work on the lookdev. And then this is this one, as you can see, the lighting is coming from the right side, and the left side is in shadows. So this is the reference that that is matching that. So let me get rid of this one. It is important that you do this, right? Because if you take a look at the actual reference here, so if you take a look at this, compare with this, as you can see, they look quite different. This one looks more contrasty and it looks more saturated, and that is because this is a TIFF, right? If we take a look at view metadata again, this is a TIFF file this is encoded as a TIFF essentially. So Windows cannot really display this very well. So as you can see here and there, they look quite different. So you need to use this as a reference and not this one on the right? So just take it into Nuke or any other software that can process TIFF properly, and just export it as a PNG or JPEG or whatever. And once you do that, you can see that it looks just fine if you use any Windows photo browser. All right. So this is the actual reference that we want to use, and I've done the same for these spheres. So again, in the texturing XYZ package, there is this reference folder, and here we have calibration, and we get all these balls. And again, I basically took this one, exported it as PNG, and it looks like that. So as you can see, we're reducing contrast and we're reducing saturation. And then you have the lighting, and these are these references from all the angles of the head. So you can process all of those. For now, we just process this one, which is our key reference. And if you go to HDRI, here you have different HDRIs that you can use for lighting. We can take a look at those. And this is how they look. So this is like a center light. This one is on the left and this one is on the right. And these ones are pretty good. And as you can see, they have a good dynamic range. And they are already color calibrated, meaning that we don't really need to do anything with the Macbeth charts. We just need to plug this into our render engine and they will look just fine. I guess the only thing we need to care about is the intensity, even though I think the intensity has been taken care of as well when they did the color correction for these maps, meaning they are normalized. And I have videos on my channel about this process if you are interested. We don't have to do it today. So the only thing that we really need to do is to control the rotation of the HDRI, and things will match just fine. Okay, so let me go here to stage, and the first thing that I'm going to do is I'm just going to create a sphere. Let me call this one gray, and this one would be something like chrome. All right, I'm going to make them smaller, something like this, and I'm going to merge them. Okay, and if I do that, I just want to put one on the side of the other one. There you go. Let me do a material library very quickly. And I'm going to go inside and create a Karma material builder. And this is going to be called gray material. And this one is going to be called chrome. Although I told you many times, these spheres are not made of chrome, they are made of stainless steel, but who cares? So for the gray material, I'm going to set my color to 0.18, which is neutral gray, with a very rough specular. There you go. And for the chrome material, I'm just going to increase the metalness to 1, and I'm going to give it a little bit of roughness, but just a little bit. All right. I'm going to create an assign material, and here I'm going to select the chrome sphere and assign the chrome material, and I will do the same for the gray sphere and the gray sphere to the gray material. There you go. So from here we can just create a dome light, and this dome light is going to be, if I go to job texture and I select my HDRI folder, here I have the 3 HDRIs, and as you can see, they are already converted to RAD. You can convert this offline, or if you just select the EXR and hit render, it's going to be converted automatically. This is what I've done here. So I'm going to select that one, and we don't have any cameras, so maybe we can just create like some kind of a camera here. Look through that camera, and I guess we need to move. Well, we can just select the spheres, lock the camera, and do something like this. So we can place the camera somewhere. All right. And if we do this and we create now a Karma render settings and select here XPU, I'm gonna select 32 samples for now. All right, let me hide that gizmo and that. If we take a look now, well, we're rendering already with Karma. Make sure that in the correction toolbar you are rendering with ACES. And this is essentially what we are getting here. So if we take a look at the reference, calibration, and let's take a look at the PNG. This is how it looks. So obviously the orientation is wrong. So I'm gonna go to transform, rotate this 180 degrees. And now we're getting closer, but I think we need to move a little bit more towards the left. So I think it's around 155 where this should match fairly okay. So if we take a look at that, you can see that we are pretty close. Intensity is definitely fine, and the reflections seem fine, and this one seems fine as well. Maybe we need to push it even more. Sorry, to the other side. There you go. So this looks pretty close to me. And as well, this sphere has a little bit of specular, unfortunately. So, well, if we wanted to match that, but that is a mistake in the paint that they use. But obviously you can add a little bit of spec there if that makes you feel better. But as you can see, it works very well. All right. So I'm gonna press D because I don't care about the background. So I'm gonna set the background to dark. This is a studio anyway, so we're not integrating anything. So I'm just gonna select black, and this matches very well. So I know this light rig is just working, and it's gonna work very well. All right. So let me just carry on with the basic setup. So let me cancel this render, and essentially, we don't need to use this anymore because we know things are working. Let me get rid of these shaders. I mean, you can keep them if you want to, but I know everything is just working fine, so I don't need to. I'm just going to do a sub import, and this is going to be my head. Let's connect it here. And for my head, I'm just going to import my head. Okay, and that's the one. So let me look through the camera, and we need to adjust the camera so we can actually see things. So I think this character is like 180 or something, so we can probably go like 160, and I guess we need to move this one. I'm not seeing anything. That's a bit strange. Okay, let me just do it this way. Okay, something like that. Okay, so, and for my render resolution, I'm gonna set this one to manual, and I'm gonna render with the same aspect ratio as my references. So let me go back to my references here, to my lighting, and I'm gonna be using this. All right, I'm gonna move this to my secondary monitor because otherwise it's a little bit tricky to work here. Okay, so I'm gonna move it on the left monitor just for a second. Okay, so this image is 4000 by 6000 pixels. So let's use that here. 4000 by 6000. Okay, and for now I'm just gonna divide this by 2, so we don't do like crazy renders from the very beginning. So this is by 2000 by 3000, which is probably good. And let's adjust the camera now. Okay. I think we're having issues with the clipping, so let's go here. There you go, 0.1. All right, let's adjust the camera a little bit more. Oh, that's too much. Okay, something like that. And maybe we want to play a little bit with the focal length, or just move it back a little bit. I guess I'll move it back a little bit. Yeah, something like that. Okay, good. Something that I want to do as well is to rotate the head a little bit. So I'm going to add a transform, and this is going to affect the head, and I'm going to rotate this like -12 or -10, something like this. And let me do that. Okay, so that looks good to me. So let me go inside, create a Karma material builder. I'm gonna call this one skin material. And for now, let's just give it like a gray shader with something like that. And let's assign this, right? So this would be the head, and we want to assign the skin material. All right. Let's render. Okay, good. And if we take a look at this is, I think, a pretty decent match, right? This looks pretty good. I think I want to, well, now that we rotated the head, maybe I want to rotate this a little bit more, the HDRI. So yeah, something like this. I think it works probably better. Yeah, and this matches even better, I think. If you take a look at this line, this works very well. So I'm gonna go with this one. Yeah, I think this looks pretty decent. Okay, great. So let me save. All right, so this is the basic setup. One thing that you probably notice is that this head is not being subdivided at render time. So we can fix that very quickly. Let me go back to my camera. So we can just go to the head. We can go to geometry handling and enable treat polygons as subdivision surfaces. So now this should be subdivided at render time. There you go. And now it's been subdivided, and the geometry should look just perfectly fine. Okay, great. So we are ready to carry on. Okay, so let me stop here for a second. And when I'm look deving a character, or actually any asset really, the way that I like to work is first on the geometry details. So that would be the displacement, the bump, the normal map, whatever. Then the roughness, and then the color map, right? Or in this case, the surface scattering. I like to keep the color for the very end, and that is because colors are very distracting. So when I'm working on displacement, I want to see how the displacement looks like, or when I'm working on specular, I basically want to see just the specular. I don't want to work on all the things. So yeah, that would be the order for this character. It would be the displacement, the roughness, the specular, and finally the surface scattering. When you're look deving, the first thing you should always do is to enable AOVs, right? So if we go to image output, because in that way you can isolate the different shader channels, and that is essential to create a good look dev. So I'm going to go to image output, render bars, and I'm going to enable the common AOVs. So beauty obviously is already enabled. I'm going to enable combine diffuse, combine glossy reflections, combine SSS, and albedo. That's everything we need. So now if we launch a render, we should have here, you know, the albedo, which is broken in Karma, by the way, the diffuse, the glossy reflections, the SSS that obviously we don't have any SSS just yet, and then these are just depth and prim ID and instance ID. These are just enabled by default, but we don't need to look at them. All right, so remember that I told you that with B faces, let's go back to here, to head maps, we get a calibrated displacement map that you can use and a multi-channel displacement map. We're going to be using the multi-channel displacement map, but we're here, so why not I'll show you how to use the calibrated map, which is very easy. It's just a plug and play. It is important information that comes here, right? This one says that this calibrated, the midpoint is 0, meaning that the point or the value where there is no displacement is 0. And on the contrary, the multi displacement channel, the midpoint is 50. So this is something that we need to obviously keep in mind while we're building this header, right? So if we go to Nuke and import, for example, the calibrated map, you can see that the background essentially is black, right? So that's the midpoint that is 0. And then we would have positive and negative values for the different features of the displacement. If we import the multi-channel, we can see that the background is gray, right? So the midpoint value is 0.5. So even if they don't tell you in the file name, and they do, you can just check it in any other software. All right, so let's go here. And again, for that calibrated displacement map, is very simple. It's just plug and play. So we just create a material X image. I'm going to call this one displacement calibrated. All right. This is a float map, right? It's a data map, not a color map. And now we can just select it. So go to job, texture, skin, and I'm going to select the calibrated displacement map, the 8K version that I created. All right. And that's pretty much it. Now we can just connect this one to the displacement. Or actually, yeah, we can just do that. Hit render and see what we get. All right. And everything explodes. And the reason that it explodes is because, well, it could be two reasons, right? It could be that the midpoint is bad, but in this case, the midpoint is 0. We know that already. And by default, what the displacement is expecting is a midpoint of 0. So that shouldn't be the case. So the only case that I can think of is that the displacement scale is just too high. And remember that the displacement scale is usually scene dependent. And because this head came much bigger than the Houdini scale and we had to scale it down in subs, now we need to compensate for that. So here, if I do something like 0.001, it should probably be closer to what we expect. It's a little bit too low, so I'm going to go a little bit higher, 0.005. And we can see that this is actually working now. Right? So give it a second. All right. And we can see that this is working quite okay now. Right? Okay, good. But there is a couple of things that we can do here to make it even better. The first one is to control the dicing, right? So if you go to render settings and you go to what is this? Rendering, geometry and shading. If you go all the way down, here we have dicing. So this is essentially how much this thing is being subdivided at render time. And this is a global parameter that is set to 1. And you should always keep it like this, because whatever you do here is going to affect the whole scene. So always keep this one to 1. And here you can select the dicing camera, and this will essentially control the dicing based on a camera frustum. In our case, we don't care about the camera, but never tweak this one unless you only have one thing in the scene. I guess for us it will be fine because we only have one thing in the scene, but it's not a good practice because then every single object is going to be diced with the same settings. So instead of doing that, what you want to do is add a render geometry settings, connect this one here, and here we can select the head. And now we should have a dicing option here somewhere. There you go, dicing. So I'm going to enable this one, and now the dicing is going to be 0.5. And you know, the less value that you use here, the more quality is going to have, right? So now this is going to be subdivided by 0.5 instead of 1 that was before. So we should get more. Sorry, the other way around. If we do 2, it's going to be subdivided more, and if we do 0.5, it's going to be subdivided less. So this is essentially how we control the quality of the displacement. So I'm going to set this one to 2 for now, right? Because we have a skin port, so we want to have really good detail there. All right. So essentially, this is going to be some kind of a multiplier of the global scale. So if you put this one here to 2, then we're in trouble, right? Because we are subdividing this too much. So always keep this one to 1 and control your different assets with render geometry settings. And of course, this can be baked into USD files and everything, so you don't have to care too much about it. And then it can be overridden as well in shots. All right. So that's the first thing that I want to do. And the second thing that I want to do is I want to do a high-res render, right? Because this is not just good enough. So we are using a resolution of 2000 by 3000, okay, and potentially 4000 by 6000, but for now, 2000 by 3000 should be okay. So another thing that I want to do, wait a second, I'm going to disable this for a second, and this has nothing to do with displacement, but it's kind of like a creative choice. So I'm going to go to XPU, and Karma is not very good with displacement. I mean, it is good with displacement, but it's not very responsive. When you make changes in the displacement, everything takes a little while. So, you know, if you're tweaking all the things and you don't care that much about the displacement at that point, let's say if I'm tweaking the lighting here, if you want to get like faster response, just go to the shader and disconnect the displacement. If you set this one to 0, it doesn't really do anything in the sense of, you know, being more performant. So you need to disconnect it and then things will be faster. So the only thing that I want to do here is in my camera, I'm going to press Shift F to see my focus plane because essentially I want to set a little bit of depth of field, something very subtle, I guess, but a little bit of depth of field. So I'm going to do Shift click like around this area. This is what I want to focus. So now I can go to sampling, and now, you know, if we set this one to 1, we should start seeing that depth of field. Obviously, we want to go a little bit more subtle. So I want to get a little bit of, you know, I want to get the ear out of focus a little bit. That's it. I don't want to do anything crazy. All right, I'm good with that. So to double check and to see that everything is working just fine, I'm going to do a high-res render. So I'm just going to go to render to mplay, and this should render at the right resolution. And we should get like a pop-up window very soon. There you go. Make sure that you set this one also to aces, and this should take very little. There you go. And now we can check that everything is working. All right. Good. So yeah, this is this simple to use the calibrated displacement. This is the only thing you have to do, and now you're ready to keep on working on your shaders. But when I take a look at my references, something that I can notice very quickly is, well, first of all, it works very well. But if I take a look, for example, at the forehead, I see that, the high frequency detail is very prominent here. I see a lot of skin pores. And if I take a look at this one, I don't see that, right? So that means that to me, the displacement is not very well calibrated, and I would like to do this myself, right? And the way to do that is by using, let me save the scene, is by, instead of using this calibrated displacement, to use this multi-channel displacement. Because again, we have the red channel with the primary displacement, the blue channel with the secondary displacement, and the green channel, the green channel with the skin pores, right? And the high frequency detail. So let's see how we can use these maps now. So here in the shader, I'm going to take, let me copy that displacement over here and disconnect this one. So this is the displacement calibrated. So we can put this in a backdrop and call this one disp calibrated or something like that, in case we want to go back to this one. And I'm just gonna move it further away because I'm not planning to use it again, but just in case. Right. So now I'm going to create another Material X image, right? And I'm going to call this one disp multi-channel or something like that. Multi-channel. All right. And this is not this is not a float image anymore. This is a RGB. So let's select vector 3. And let's select the displacement multi-channel AK. There you go. Okay, good. So now, we need to change a couple of things here, right? So first of all, the displacement strength, we don't know if it's going to match what we had before. So this is something that we probably need to tweak. Generally speaking, in my experience, this comes with a little bit more strength, so we probably need to reduce this, but let's see. But the good thing about the displacement multi-channel is that we can control the primary displacement, the secondary displacement, and the high frequency displacement independently, right? So we need to separate those channels, and then we need to essentially mix them again, right? But first of all, remember that this is a mid 50, right? So, well, let's start by just connecting it here and see what happens. And to make things faster, I'm going to, well, actually I forgot to enable this for my final render here, which is not good, because it would have been nice to see how much the dicing affects the result. So, my bad. So let me actually do another render with the displacement that we had here before. All right. I just want to make sure that it's looking better with the dicing at 2. All right, I'm going to render to endplay, and this is going to take longer now because it's going to take more memory. So it's better if I pause the video and I come back when it's done. Okay, it's done. So first of all, you can check that the render time was 2 minutes and 23 seconds, while the previous render was only 17 seconds, and it took 12 gigabytes of RAM, and this one took 43 gigabytes of RAM. So obviously dicing has a huge impact in your render. But in terms of quality, I don't know how much you can see through the video compression, but to me this is crystal clear. Like, this is all very soft, and here is much sharper everywhere. Again, I don't know how much you can see of this, but yeah, it's definitely much better with dicing at 2. I don't think it's worth it going over 2 If you go to 4, it's going to take way longer to render, and I don't think you're going to get much more extra details. But between 1 and 2, it's a big step, right? And obviously, if this is in a movie and it's a character that is moving and there is motion blur and all of that, I would never use a Dyson of 2. That would be a waste of resources. But here, it's just a still frame. This is the only thing that we have in the image, so why not? All right. But yeah, obviously we still have the same issue, and now it's even more evident that all the skin pores in the forehead doesn't make a lot of sense compared with our reference here. And this is the whole render, but if I do one-to-one zoom, this is how it looks. And so always render at least at this resolution to check all the details. All right, good. But let me go back to what I was saying before. So for now, I'm just going to disable these render geometry settings, so my renders are faster. And as I was doing before, let me disconnect this one, connect this one back. All right. So we were working on the displacement multi-channel. So if we render this straight away, well, the first thing that we see here is that everything explodes, and everything explodes because this displacement multi-channel has a mid point value is a mid 50, right? So we need to subtract that information to take it down to 0, and that is very easy. We can just add material X subtract. So the first input is going to be the displacement, and the second input, the second input has to be 0.5, right? So by doing that, we are taking the 0.5 default value to 0, and then things shouldn't explode. There you go. Now things are working just fine. Okay. Good. But I mean, I don't know if you can see it here. I don't think you can. So probably the best way of double checking is again by doing a high resolution render. Now it should be faster. It will look worse because of not using dicing, but it should take like the first one, which is only 17 seconds or something like that. So, and to do like a fair comparison, I'm going to delete this second frame, which is the one with dicing. So I'm just going to press delete. Right. So now we go from this one to that one. As you can see, things don't look good. Things look very weird. Right. And that is because we're not really doing anything to every individual channel. So let me delete this one because it looks horrible. All right. And let's see how we can combine all those channels properly. All right, so we know that this is working, the subtracting is working, so things are not exploding. So how can we isolate the channels now? Well, I'm going to use a separate color, right? So we do this here, and now we have red, green, and blue, which is essentially what we have in this displacement multi-channel, right? So now if we want to control each of these individually, we can just do it with a multiplier, right? So if we create a multiply here, we can connect this one here, and I'm gonna tint this one to red. So this is the red channel. I actually like better this other red, all right? Then here it would be the green channel. And here I'm gonna connect the blue channel. All right. Good. So now, each of these has a value of 1, meaning that we're not really doing anything to them. But if we want to control the strength of each of these individually, we can just do it here, right? Good. And now, to combine all of these back again, we can just add a material X add, and we can combine all of these. So I'm going to take this one and this one. And by the way, other render engines have better tools to do this. Here we need to do it with low-level tools, which is fine because then you know what you're doing. But you know, in RenderMan or in V-Ray or in Arnold, you have layer shaders that you don't have here. I mean, here you have the Material X layer, but this is a different thing. This is to combine BSDF signatures, so it doesn't work like that. So you need to build everything from scratch, which is fine. And now here we can combine this one and this one. And right now, if we connect this one to the displacement, okay, that looks weird, but it should be fine. This is probably just a pure glitch. But right now, we're not really doing anything, right? We're taking this map, we are subtracting 0.5, we are separating the channels. They are here separated, ready to be tweaked with these values. We are combining them and connecting them. So we're not really doing anything, right? So if I render this again, okay, now everything is working, but we're not really manipulating the data. So the first thing that I can see, and to see things properly, I need to do like a proper render because this viewport is not good enough. I mean, usually what I would do if I don't want to do like, you know, M-play renders all the time, I would work with 2 monitors and I would have my scene view in just one big monitor, and this would be much bigger. But because I'm recording a video, obviously I cannot do that. I cannot have 2 monitors, so that's what I'm keeping this here and just launching M-play renders all the time. And yeah, this is how it looks. And as you can see, all the maps are combined and it looks good. But if we compare this with the calibrated geometry, sorry, with the calibrated displacement, we can see that the strength is different between these maps, which is expected. So we just need to compensate for that a little bit. All right, so let me go here. And this strength that we use at the beginning, I think I'm going to reduce that by half. All right, good. Let me kill this render and delete it. All right, and launch a new one. And let's see how this looks. Okay, so still rendering, but if we compare this with the previous one, yeah, this looks pretty spot on to me. Yeah, it looks exactly the same. So yeah, we had to reduce the intensity by half. I don't know if this formula works for every single B phase that you can download from the website. Probably not, but you know, it's just like playing with the values a little bit, and it works exactly the same in this case. So this is all good. So this is all working, right? But now, and we get this viewport glitch. I guess it will update at some point. Maybe try to do like a labs reset viewport and see if that improves anything. No, still there. Well, anyhow, who cares? This is just a viewport glitch. As we can see, it works fine in the render, and that's what matters. So yeah, as I was looking at this reference, what I can see is that, for example, the high frequency detail is just too much in some areas, like the forehead, for example, right? But the good thing is that now we can control all of these independently. So that will be the primary displacement, the secondary, and the high frequency. So I'm going to take the high frequency and set it to 0, right? And let's do another render and see what happens, right? I'm not pausing the video because this takes very little time. So I'm just, you know, you're probably watching this like 2x speed anyway. So let's see how it looks now. Right, cool. So if we compare this now with the previous render, maybe let's wait a little bit for this. Yeah, if we compare this with the previous render, now we're removing the skin pores, or well, not all the skin pores, but most of the skin pores because they are in the blue channel of the multi-displacement texture, right? So if you take a look at the forehead, for example, now we're reducing that by a lot, but we're reducing it also on the nose, right? And on the cheeks, on everywhere really, because we're removing that map, right? And this is a really good way of just seeing what these maps are doing, right? So if I take these two and set them to 0, now we wouldn't have any displacement. Now I'm gonna set this one to 1 and see what the high frequency detail is doing by itself. So let me render this again. All right, so now as you can see, I don't have any primary or secondary displacement. I only have the high frequency displacement, which is these skin pores, right? Okay, good. And obviously this is going to look even better once we enable dicing, right? But yeah. And again, if you want to increase the strength of any of these, because so far we have been just decreasing the strength, but if you want more here, you know, if you set this one to 3, now your skin pores are going to be crazy. Let me zoom in here. Again, when you're using displacement, it's a little bit slow. But yeah, now we're increasing the strength of the skin pores. All right, but I don't want to do that. So I'm going to keep all of these at 1 for now. And this is the original displacement. So yeah, in my case, I want to reduce the intensity of the skin pores on the forehead and, you know, potentially other places. But this wouldn't work, right? Because this will affect the entire face. But now is when we can actually use the isolation masks, right? Which is what we're going to do next, right? But before we do that, I just want to show you another thing. Like, what if I want to sculpt any extra details in ZBrush and just print them as an extra layer? Well, that's very easy, right? So if I go to Nuke, if I go to extra maps, I created like a texture here, which is this, and this is just like a scar that I did on the face, on the, you know, around the mouth area of the character. So let's see how we can use that one. So I'm gonna use an image, Material X image, and I'm gonna call this one disp scar, right? And the way that I created this displacement, if I go back to here to Nuke, you can see that this is also like a 0.5 midpoint displacement. So we also need to add a subtract here and subtract by 0.5. Okay. And most likely we need to add a multiplier later. Oops, my bad. Oop, this is very laggy. We need to add a multiply to control the strength. So I'm gonna put it here, and I want to connect this one to the displacement. So now we only have the scar. We don't have any of that because I want to see how this looks. Okay, so it doesn't seem to be working very well. Let me see what's going on. Oh, first of all, oh yeah, I didn't select the texture. I'm stupid, my bad. So I'm gonna select this one to float and select the texture. So I think it was scar 7. I did a few iterations here until I liked it. Okay, let's render again. All right, so here you have the scar. Let me zoom in a little bit. And well, the problem when I'm zooming in, obviously, well, now I'm outside of the camera. Okay, good. Because otherwise, I would have a depth of field. So this is my scar. I'm going to increase this a little bit, maybe by 3. And obviously this will also look better with dicing. But yeah, this is just a scar that I did here on this area. And it's just looking fine. What am I getting? My background. I want my background to start. Oh, because I reset it before with this tool. Okay, so I have that scar there. And as you can see, the only information that I have in this layer is the scar. So that's what I exported from ZBrush. So now, if you want to combine that with the rest of your displacement, it is as easy as just adding that, right? And because everything is in the same range of 0.5, I can just add this like that. All right, and connect this one to the displacement, and things should work as expected. So let me do like another render and play so we can take a look at everything in high res. Okay, and now this is how it looks once we combine all the layers. So we have exactly the same multi-displacement channel that we had before, but now we are adding this scar on top. All right, good. So that's basically how we combine this B-face displacement with other custom displacements. All right. Oops. So what I'm going to do now is I'm just going to disconnect this, and we can call this one something like displacement multi-channel simple. Because what we want to do now is to take this setup that we have here and use the isolation masks to control the parts of the head that we think are not very well balanced. Like, for example, the forehead, right? We saw that we have just too much high frequency detail on this forehead compared with a reference. So let's make a little bit of room here. And let's move this out of the way. This will be like our second setup, but not the one that we're going to be using. So let me move it far away. And we can recycle a couple of things here. So we're going to keep using the multi-channel displacement. We're going to keep using this subtract to put everything to 0.5, the separate and the 3 different channels, everything set to 1, so we're not really changing anything. So I'm going to copy these 3, and that's going to be the base of my displacement, right? Okay. Now, we want to import all the isolation masks, or at least the ones that we're planning to use. So I'm going to essentially, let's do it from scratch. Let's do a material X image, and this would be the ISO 1. This is also a vector 3, right? We have 3 colors here, so let's bring the ID mask. So that would be the first one. All right. So here, again, if we go back to Nuke, let's bring one of those. So if we bring one of these, we can see that again, this is an RGB map. So in the red channel, we have the forehead. In the green channel, we have the nose. In the blue channel, we have the cheeks. So what I'm going to do is I'm going to add a quick note here, and I'm going to say The red channel is equal to the forehead. The green channel is, don't remember now, the nose. All right, it's the nose, and the blue channel is the cheeks. All right, so we can have this information here. All right, let's separate this into red, green, and blue. So we can copy those if we wanted to, just because they have nice colors already. So we can put this one there. We can put this one here and that one there. And again, all of these are multiplied by 1, so they are really doing nothing, right? So let's do the same for the others. So this would be ISO 2. All right. And ISO 2 is eyes, lips, and ears. So let's put that here. Eyes, lips, and ears. All right. Let's duplicate this one more time. Select the ISO 3. And the ISO 3 is the neck, the back of the head, and the top of the head. So we can call that essentially the same, right? So we said neck, head, back, whoops, and head front. All right, and we're just missing one last map, which is the ISO 4. And the ISO 4 is the chin, the mustache area, and the tip of the nose. So let's call this one chin, mustache, or mustache area, because it's not really the mustache, and the tip of the nose, nose tip. All right, so now we have everything that we need here. Let's make a little bit of room. Okay, so now what we need to do is to basically combine all of these, right? So let's start by doing that. So we can add an add node here, combine these two, duplicate this one, and combine that. And we need to do the same for all of them. And again, other render engines have nodes that can do all of these in one single node. Karma and Material X don't have that, so you need to rely on low-level tools. But these other tools that I'm talking about in Arnold or RenderMan or V-Ray, they do the same thing under the hood. So again, it's a good thing that we're doing this kind of from scratch, because then you know what these other tools are doing under the hood. All right, let's combine the last one. Cool. So now if we combine all of these, we would get like a full representation of the face when it comes to isolation masks, which is what we want to do. All right. So now is when we can control all of these, right? So again, these are overall controls for the maps, and you know, we can still go to this one and reduce it by half, and that will work, but it will affect the entirety of the face. So in this case, we don't want to do that, but it's nice to have these controls in case we need to use them. But now, so in this first ISO 1, the red channel is controlling the forehead, right? So how do we control the strength of the high frequency detail that comes in the displacement, but affects only the forehead? Well, and we can do that with just multipliers, right? So if I add a multiplier, and now I want to affect the high frequency, right? I want to multiply that by the result of this. Okay, so now if if we go to the red channel here, which is the forehead, right? Remember, this is this map here. We can control how we are affecting the high frequency detail here by reducing or increasing the forehead channel or the nose or the cheeks. So for now, let's do nothing. Let's keep everything at 1, right? Cool. I'm gonna do the same here. I'm gonna add another multiplier. These would be also connected to the first input, that one to the second. Let's add another multiplier, again, from the high frequency to the combination of all of these. And another multiplier here, and same thing. We take that one, pipe it here, pipe it there, and that should be essentially everything that we need. All right, now we need to add all of these. So let's come back here. So let's add and add, and let's connect this one here, that one there. Let's add another add node and connect this one and this one, and we need another one, right? So another one here and here, and this is basically how we can control all the areas for the high frequency. In this particular exercise, I feel that the only thing that I want to control individually per area is the high frequency detail. If you want to do the same for the green channel of the displacement map and the red channel of the displacement map, well, it is as easy as just duplicating this whole setup and doing the same thing. But in this case, I don't want to do that because I think that's overkilling, and these maps are very well balanced, and the only thing that I want to control is the blue channel. But again, it's just adding the same operations for the other channels. And finally, I'm just going to combine everything, right? So I'm going to combine the red and green channel here with the results of the blue channel, which is this. So let's just add another add here, connect that one there, and connect this one here. And let's move this, let's move that. And this should be our displacement map where we are controlling everything with isolation masks. Right now, all the values here are set to 1, right? So we are not really doing anything, but well, we need to plug this into displacement to check that everything is working. So let's do that. And let me render this. Okay, it is rendering. It seems that everything is okay, but again, it's hard to judge. So I'm going to do like a proper render to mplay. If we go here, I guess the new render would be the same, but without the scar. So same as this. So I'm gonna get rid of this render and wait for the new one to come. All right, it is rendering now. So let's wait a couple of seconds. There you go. And if we compare this one with that one, we can see that we get exactly the same. Well, we have more noise now because the rendering is still at 20 something %. Let's wait for it to clean the noise a little bit more, but we should have the same, right? Okay, good. So now is where we can start controlling the areas. So again, when looking at this one, I want to reduce the amount of high frequency detail on the forehead compared with this, and also on this ear, well, both ears. Here we don't see it much now because of the depth of field. So sorry, let me re-render this again without depth of field, because when I was testing these maps earlier, that's what I saw. Let me get rid of this render. Okay. So yeah, forehead is definitely too much, and the ears, you can see that we have a lot of skin pore detail inside of the ears and everywhere. And when we compare it with this, here is much softer, right? So I want to control those two areas, and I don't feel that I want to control anything else. So let me go here. So now, if we just go to the first ISO mask, this one is controlling the forehead, right? So I'm gonna reduce the intensity to maybe something like 0.5. And now, where do I have the ears? The ears are in the blue channel here. So I'm gonna do the same thing, maybe like 0.25. And the rest is going to be, is going to remain at 1, the rest of the parts of the head, which I'm happy with. Okay, so let's fire another render. So this is without any modifications, and we're gonna get the new render very soon. Okay, here it is. So if we compare this with the previous one, you can see that now the forehead looks much better in the new version. Also the ears don't have that many skin pores anymore, and everything looks a little bit more natural. And when we compare, let's go full frame here, when we compare that with these, it looks much closer, right? Cool. Maybe you can tell that maybe the point of this, the nose, we should remove it a little bit more. Yeah, we can do that as well, right? So maybe we can come here. Let's go to the nose tip and maybe do 0.5 as well. I think that's probably the only thing. The rest looks very good to me. So I'm gonna do a render, like a proper render, this time with dicing set to 2, because this will be our final displacement. So I wanna check like the full quality of what we're doing. So I'm gonna render to end play. And again, now it's gonna take like 2.5 minutes or something. So I'm gonna stop the video here. Okay, so this is the render at full quality. And as you can see, everything looks super crisp. We got a lot of detail everywhere, and all the channels of the displacement are very well balanced. And now it is looking much closer to the reference. I'm quite happy with it. Yeah, so essentially this is how you deal with your displacement mapping, just by isolating all the different parts. And yeah, essentially this is how it works. Okay, and again, if you want to have extra control over these 2 layers, you just repeat the same setup. Okay, and obviously something that you can do if you are working with this type of material all the time, well, you can create like a proper template with controls. You would create like a null or something, and here you would expose your controls with all the strength for all the layers, so you don't have to come here, right? You can have that control even like a stage level or something. You will make this into a tool, right? Okay, and just to make sure, a good thing, a good way of checking that your isolation masks are working fully. let me just disable the dicing so everything goes faster. One way of checking that everything is working just fine is if you take your output of the isolation masks and you use it, let's say, as emission color for a second, and set the emission to 1. I'm going to take the emission, set it to 1, and I'm going to take my base color to 0. So if you render this, you should get all the isolation masks to display as a color, essentially. Whoops, that didn't work. Why not? Okay, let me check what I've done wrong. Oh, sorry, my bad. I'm just multiplying it by the displacement as well. My bad. Sorry. So let me disconnect the displacement for a second here, and let me add an add where essentially I just wanted to plug all the isolation masks here. So the 1, 2, now it would be this one here, this one here, that one goes here, and another one, and then we do this, and that. Okay, this should give us all the isolation masks combined. There you go. So now this is a good representation of you know, how your masks are being modulated. So everything is white except for the areas that we reduce. So, you know, this is a nice way of checking that everything works. All right, just as a debug thing. But we can get rid of that. We can connect this one back to the displacement, and we don't need this. All right, and let's set this one back to 0. And this one back to 1. All right, so this is the displacement setup. So we can just take this, put it here, and we can call this one something like disp multi-channel plus ISO masks. All right, good. And this is the displacement that we're going to be using today. All right, great. So let's move on to the next shading channel, which is the roughness. And the roughness should, you know, the roughness is an illusion. It doesn't really exist in real world. Or in other sense, or in other way of explaining this, roughness is essentially it is essentially an effect that happens when a surface breaks into smaller details, and we're getting that from the displacement. So I should say that, you know, this roughness is very representative of what you should get. And if you take a look at this, it's not that far, right? So maybe we can make the decision here of, you know, changing things artistically, not physically correct maybe, but artistically correct, which is what really matters when you're doing visual effects. So we can do the same thing with the isolation masks as well, right? So the first thing you need to do is to set your index of refraction, and yeah, I'm gonna keep it something between 1.4. I think skin is something around 1.44, something like that. So something between 1.4 and 1.5 shouldn't affect that much. And then I want to set like a base roughness. So 0.6 has been working quite well, but I think we can go a little bit oilier. So something between 0.5 and 0.6. So I'm going to do that by just creating a multiplier. right? So I'm gonna keep my input 1 to 1 and my input 2 to 1. So yeah, I'm gonna multiply 1 by whatever I think is at the right amount to start with. And again, it's gonna be something between 0.5 and 0.6. So let me go to 0.55 and I'm gonna connect this one to the specular roughness. Just make sure that everything is correct. Yeah, the specular should be set to 1 and the color set to 1. All right. So, and let me double check that this one is disabled. Yes, it is disabled. So my renders are fast. So now, if we render this, let's say when it starts, now my base roughness is 0.55, right? If I take this one down to 0.3, it should be more oily, right? And remember, you have your AOVs here, so you can always check the combined close reflections, so you can see what the roughness is doing. But again, I'm gonna set mine to start with a value of 0.55. All right, and this looks good to me. Let me go back here. Oops, my bad. Sorry. There you go. So yeah, when I take a look at here, what I can see is that my the areas where the skin seems to be a little bit more oily are the forehead and the nose tip. So I want to control those individually, right? So let me go back here. Let me stop the render for a second. So I'm gonna add another multiplier, and I'm gonna connect the first multiplier to the first input. Oh, actually, no, to the first input. You know, we could do it this way, or yeah, let's take a look at another thing. Instead of a multiplier, I'm gonna use a mix. I think this is probably better. So I'm gonna connect this one to the background, right? So because the background is my base value, which is 0.55, right? And for the foreground, I'm going to use a different value that corresponds to an area of the face that I want to control. And that would be the forehead, right? So let me grab the forehead from here. So, you know, this is essentially the forehead. So I'm going to connect this one to the mix. Connect this one to the specular, sorry, let me expand this. All right, that's better. I'm gonna connect this one to the roughness, and now we can control this, right? So we're using a value of 0.55. So now I wanna use a value that is a little bit more shiny or more oily for the forehead. So maybe I'm gonna use a value of 0.35. Okay. Good. And now I'm going to do the same for the nose tip. Okay. So let me create another mix. This one goes to the background. And for the mix, I'm going to use the nose tip, which is this blue channel. There you go. And I'm going to use a value of the same, 0.35. So, you know, the forehead and the nose tip have the same oiliness level, right? But obviously you can tweak them. But just as a starting point to see how things look, this is what I'm going to use. All right. And do I want to control something else here? Yeah, maybe the cheeks, I can do something to them. I mean, just as an illustration point, yeah, because the cheek seems a little bit more oily here than I have there. So let's add another mix. All right. Let's connect this one to the background and let's grab the cheeks. Where are those? I think in the first one, right? So it's the blue channel. Yep. So let's connect it there. And let's use a value of something that is not that oily, because this one is quite oily, this one is quite oily, maybe something in between, like half of what we have. All right. And now let's connect this one to the specular roughness. Let's organize this a little bit better. Let's move it down here. All right. And I'm going to render this. Okay, let's take a look. Cool. And this is how it looks. Now, as you can see, the forehead is a little bit more oily, the cheeks and the nose tip. So if we compare this with the previous render, there you go. You can see that hint of specular there. Maybe it's too much, I don't know. It's hard to tell until we balance the rest of the maps, which is the specular and the subsurface scattering, because the subsurface scattering will, it will get rid of some of the detail, both the displacement and the specular. So let's see. But when I look at these, the forehead looks very close to me. The tip of the nose looks also very close to me. The rest of the skin looks very good. My only concern is maybe this part of the cheek is a little bit more oily than here. But let's see. We need to check once we add the rest of the maps. But it looks better than before, right? Before it was too dry. Now it's a little bit better. So this is a really good way. Also, the ears are looking very nice. So yeah, it works very well. All right. So the next thing that I'm going to do is play a little bit with the specular. So I'm going to place this in a backdrop, and this is going to be called roughness. So the specular, I don't really do much to it, the specular should always be 1 and color 1, and the roughness is the one that takes care of that. But again, this is an artistic choice because we have the utility map, if you remember, and the utility map, it has different channels that you can use, like the red channel, the green channel, and the blue channel. So maybe I'm planning to use this blue channel to, modulate a little bit inside of the skin pores, so we block a little bit the specular inside of the skin pores. Again, this is an artistic choice, and I don't always do this, but sometimes I do it. So let me grab a Material X image, and that would be my utility here. All right, so let's call this one utility. Good. I'm going to separate the channels as well, because I only care about the blue channel. The blue channel is where I have this, right? This is the blue channel. So let's keep the blue channel only. And now my original specular value is 1. So let's use that as an original value. So again, we can just create a multiply 1 by 1. All right. Now we can add a mix, and we can mix this one with the blue channel as a mix. And then for the background, sorry, it's the other way around. So this one goes in the background, this one goes to the mix. And now this is the control for the skin pores. So if we keep this one like that, essentially, it would be the same. So maybe I'm gonna bring it to 0.5. And now we can connect this one to the specular color, to the specular value rather, right? So let's go here and connect it to the specular value. And let's see how much this changes now. Okay, so now, as you can see, we're blocking a little bit of that specular. We can actually take a look here at the glossy reflection. So, we went from this to that. So now you can see that we are blocking a little bit the specular on the skin pores, which looks a little bit more well balanced, I should say. Instead of getting these flat speculars here, we're getting something a little bit more broken up. And if we go back to the reference, that looks very good to me. That looks very good to me. It was a little bit too much before, so now it's looking a little bit better. So again, maybe this is not the right value. So maybe you want to go back here, and instead of using 0.5, maybe you want to use 0.7 or whatever. I mean, just playing with the value. I'm just giving you the recipe here, but based on what I see, I think it looks slightly better than before. Maybe too much. Maybe I killed too much. I don't know. But based on the reference, it looks quite close, right? But yeah, maybe I could push it a little bit. Maybe 0.5 is too much. Maybe 0.6 or 0.7 will look better. Okay, I'm gonna leave it at 0.6 and see what happens. And this is my specular. All right, my specular intensity. The color should always be white. Okay, which is this, right? In my shader, it's always white. All right, good. Cool. So I guess we are only missing the color. So the color should be pretty straightforward. So let's just bring the color, which would be the albedo, the AK version. So let's call this one albedo. And most likely we're going to have to color correct somehow the albedo. I'm just assuming that because you always have to color correct albedos. But I'm going to connect this one to the base color. All right. So that would be my base color with a strength of 1. That's everything we've done so far. So for the subsurface scattering, sometimes I use a value of 1, which would be physically correct. But in many cases, I tend to use a value of 0.8, 0.7. So I let the base color to pop up a little bit. And again, I know that's not physically correct. Your subsurface scattering should be either on or off. But again, based on my experience, this tends to look a little bit better, and especially with Karma. I don't think I tend to do this much with Arnold or Renderman because those look much better. I mean, those are better shaders, honestly. So here I need a little bit of punch from the base color. Otherwise, it seems like it's losing the volume quite quickly. So I keep the subsurface scattering somewhere between 0.7 and 0.8. All right. So I'm going to connect that one to the base color, but also to the subsurface color. So I'm going to connect this one to the subsurface color here. All right. So here we have it, subsurface color. Cool. The other thing that we need to deal with is the subsurface scale, right? And the subsurface scale, again, it is scene dependent. And because we scale this quite a lot, we're going to have to reduce it. Otherwise, it's going to look very funky. I'm going to keep it at 1 so we can see how funky it looks. And the radius is usually, the dermis you're going to be controlling the color of. So I'm going to keep this one at something like 0.35 and 0.2, something like this. So this will be my color. Depending on the skin color of your character, you would have to play with different colors. This is something that usually looks okay for Caucasian people. Another thing that you can do is use exactly the same map. Just use color correct here and play with the colors until you get something similar to this color. I just want to give you this value because it's something that I use quite a lot. And it looks quite decent. So I'm going to keep it that way. Okay. Right. So let me do a quick render here. And two things will happen. The first one is that it's going to look ridiculous, and that is because the scale is just too big. So again, this is scene dependent. So I'm gonna reduce this to 0.001. And hopefully that should look a little bit better. All right, that's starting to look a little bit better. Obviously, surface scattering is a very, very heavy shader. So usually surface scattering and volumetric shaders are the most expensive one. So obviously you expect like long render times. But as you can see, this is looking quite nicely. One issue with the surface scattering is that it will decrease the perception of your displacement map. So if I go to my, well, this is the contribution of the base color, by the way, and this is the contribution of the surface scattering itself. So if we take a look at the glossy refraction, we can see that we have still the nice displacement detail, but surface scattering will eat a little bit of that detail. So what I tend to do is to increase a little bit the strength of my displacement, just because I lost some details. So I'm gonna take that one to 0.035, and hopefully this will look a little bit better. All right. Yeah, this is a bit heavy to render now. So, all right. Sorry, I moved the camera by mistake. Something that I want to do here is, let me stop that for a second. Or actually, sorry, my bad. Let me bring that back. When I take a look at these on my render, my reference, I can see that this looks a little bit more saturated, and probably it has a little bit more contrast than this reference. So what I'm going to do is I'm going to add a color correction. I haven't seen the day yet where you don't have to color correct your albedos. So this goes into the input. And what I was playing with this a little bit before. So what I ended up doing was to reduce the gamma a little bit. So I'm going to reduce that to 0.8. Okay. And I'm going to connect this one to the base color. I might want to do a little bit more color correction. I don't know. I think the saturation I probably want to reduce a little bit. So let's keep this one for now. I'm going to add another color correct. Connect this one here. And for this color correct, I'm basically, or actually, wait a minute. Let me get rid of that one. Instead of that, I think I'm just going to control that with a multiplier, because I want to, yeah, maybe a multiplier is better. So essentially what I want to do is take this color correct to the first input, and now I want to bring a little bit more redness to the SSS, so it feels a little bit more alive. So I'm going to keep the red channel to 1 and reduce this just a little bit, maybe by 9.75. And now I can connect this one to the surface color, and this one is connected to the base color. All right, something like this. Okay, good. So yeah, and I was thinking that maybe reducing a little bit the saturation as well. So I'm gonna set this one to maybe 0.95. Let's see if I have to reduce this a little bit more. I'm not sure. Let me just render this and see what I get. Okay, this is still the old, so this is what we're getting. Yeah, I think I think the redness here is just too much. I mean, it's nice to get a little bit of redness there, but yeah, this is probably just too much here and probably here. So let me go back to 0.8. All right, something that like that looks a little bit better. I'm gonna add a multiplier to the diffuse. And I think I'm gonna reduce the redness here because it looks very, very red to me. So maybe 98. Let's see how that looks. You don't want to push it too far because then it's going to look like a dead character. Is it doing something? Let me go crazy to see what I get. I don't think it's updating. Now it's updating. All right. 98. Okay, that seems fine. I might pass that to the SSS as well. So let me connect this one here. Let's see when it updates. Okay, let's take a look at the full picture. And if we take a look at these two, I think it's still too saturated. So yeah, I mean, it's just a matter of controlling the saturation a little bit more. And maybe the contrast a little bit more, right? So let's do perhaps, okay, I like the base. I think the base is fine. So just to keep things separated a little bit, I'm going to add another color correct here. I'm going to desaturate this a little bit more, like that. And maybe reduce the contrast a little bit, like that. And I think now this is just too much, probably. Let it converge a little bit more. But yeah, I think now it's just too much. So I'm gonna do 0.95. And see if this looks a little bit better. Okay, let's take a look here. And that looks a little bit closer to me. We might still have a little bit too much of red. So again, to do the final matching, we can just do that in Nuke, but this looks pretty close to me. All right, good. So yeah, this looks pretty close. I'm wondering if here, can we split this gamma in 3? No, I don't think so. Okay, anyway, yeah, this looks quite close. It's just fine tuning now. I think we can reduce a little bit more the redness. So you either keep doing it here. What if I go all the way to 95? I have the feeling this is going to be just too much. But let's see. All right. Yeah, that looks pretty decent. All right, so I'm gonna keep it like this, and yeah, that looks pretty nice to me. Okay, let me stop the video, and let me import the pitch fuzz. So I created this layer of pitch fuzz, which, if you don't know anything about grooming and hair in Houdini, I have my series of grooming on Patreon. So you can check that out. This is not a video about grooming, so I'm not going to explain this, even though it's extremely simple. I just painted like this attribute here, which is the fuzz. So I remove the, the interior of the ears, the nose and the lips, so we don't get any hairs from there. And then I just created this hair generation here. So we are creating all this hair, right? Which I kept long, but it's fine because we don't see that much. Cool. So now if we go back to Solaris, I'm going to sub import that. So I'm going to call this fuzz. Go inside and bring my hair generation. So here we have it. I'm going to apply the same transformations here. So it rotates with the character. There you have it. All right, good. And then I'm just going to create like a quick karma material builder. I'm going to call this fuzz material, and I want to use hair shader. I'm just going to connect this one to the surface, and I think I'm going to increase the melanin to something like 0.8, so it's not that blonde. And that's pretty much it. I don't really want to do anything else here. So now, oops, my bad. What did I do? I exchanged the position of these things. That's not something that I wanted to do. Oh man. How did I do this? Oh. All right. Can I reset this workspace? Reset. Reload current desktop. Okay. There you go. Back to my camera. So I was trying to assign the shader here. So let me just assign the fuzz primitive and the fuzz material. There you go. Render this. I guess I need to change all of this again. And my background as well. There you go. And now we have some pitch fuzz in there. All right, good. So this is pretty much it. There is one thing that I want to do before final rendering. So let me stop this. I want to get those isolation masks as custom AOVs so compositors can use them in Nuke, right? So I'm going to go to my skin shader. All right, to my skin shader. And here I'm gonna create a karma AOV. All right. I'm gonna take my isolation mask 1, which is this one, right? And I'm gonna connect it here. All right. For AOV name, I'm gonna call this one ISO_1. All right. And I'm gonna do the same for all of them. So that would be ISO2. Connect it there. Rename it to ISO2. This one would be ISO3. Let me connect it to the ISO3. And we're just missing one. So this one would be ISO4. And I'm going to connect this one to ISO4. That's pretty much it. All right, so that's done. So now in my Karma render settings, oh, before I forget, I'm going to enable depth of field again. In my image output, I'm going to go to extra render bars. I'm going to add a new one, and I'm going to call it ISO1. Okay. The source name should be the same that I typed in the shader, which is ISO1. And the format is going to be color3 float, right? Because it's an RGB map, it's a vector map. So that should be it. All right, so if I do the same for the others, ISO 2, color 3 float, ISO 2. All right, now I'm going to use the ISO 3, color float, and ISO 3 as well. Okay, and we're just missing 4. So that would be 4, color float, and 4. All right, so let's see if this is working. So if I check my, well, it hasn't started rendering yet. Just give it a second. All right, it hasn't started yet. So let it cook. Come on. Oh, sorry. I'm stupid. My bad. My bad. Let me cancel this render. It's showing up black, obviously, because I forget to make the connections in the shader, right? We created the AOVs, but we never made the connections. So obviously this is not working. And this is lagging quite a lot, so I feel that my Houdini is going to crash. Otherwise, I'm going to have to restart it because it's super slow now. All right, let me go inside. Let me go here. And I forgot to make the connections, right? So obviously, we just created them, but now we need to connect them to the shader. There you go. And now it should work. All right, let's give it another go. All right, so now this should work, right? So now we have AOVs for all the isolation masks. And then compositors can use these in the shots with an animated character to control things depending on whatever they need, right? All right, great. So finally, I'm going to enable my dicing to get the proper displacement quality. And in my Karma render settings, I'm going to increase my sampling to 128 because the subsurface scattering is a very heavy shader. It's very noisy, so you need a lot of samples to get it properly. So I'm going to do 3 different renders, rotating my light around so it comes. All right, so I rendered 3 frames, rotating the light around and just combine them here. So, you know, these are the individual renders, that one, that one, that one. And then I just merged them together to have them here. And as you can see, you know, everything is looking spectacular. Roughness is very well balanced. Displacement is very well balanced. The SSS looks very realistic to me. Again, not my favorite SSS shader. I have the feeling that if I render this with Arnold or Render Man, it will look even better. But I think it's a pretty good result, right? We can see the pitch fuzz in some areas. It's very subtle, but you know, it looks very nice here on the chin and on the cheeks and ears. It looks very cool. So that's pretty much it. Obviously, we're rendering with ACES. So if you import your image and it looks a little bit weird, right? One way of fixing that is with an OCL color space, and make sure you are moving from linear sRGB to ACES-CG, and you will go from this weird image to the correct one, right? And now things look very nice. All right. So if I go, let me go to my Houdini project, renders. There you go. So this is the render out of Nuke, which looks very nice. And this is just a clay render just to see how everything works without displacement map. And here you can argue that the displacement is a little bit too strong, which it is, and that is because I increased it. Remember that we increased this together in Houdini because we're losing some of the details with SSS. So if you want to do like a nice clean render here, I would reduce a little bit the displacement, because here it looks a little bit too strong to me. But once you add the SSS on top, it just looks totally fine, right? And again, when we compare these to our reference, you can see that it's very spot on, right? It looks very, very close. Again, it's just a matter now of, pixel fucking around. Like, you can argue that maybe this specular should be a little bit more oily compared with this one, and I agree. So you know how to tweak that. The cheek, I think it looks great. Maybe here we could get a little bit more specky feeling as here. We don't have a mask for that, but you can just paint a mask in Mari and use it in the same way that I show you. And then the rest looks very cool. I'm quite happy with how this is looking. All right, good. And of course, in Nuke, if I go here to one of these, if we add a shuffle, I haven't done any corrections or anything, but in your shuffle, you would have your isolation masks. So you can use this for color correcting Nuke, or your compositors can use this. And of course, you would have also your regular AOVs like combined diffuse, combined closer reflection, and SSS. So you have a lot of control here. All right, good. So yeah, that's essentially everything that I wanted to talk to you about today. So yeah, let me know what you think. But hopefully we cover pretty much everything when it comes to skin look dev. There are other things that you can do, of course. Like, remember, the utility map has other channels there that you can use for controlling the SSS. Something we didn't do is controlling the SSS in different areas of the face, but you know how to do that already, right? If I go back to Houdini, if you want to control the SSS for different parts of the head, you can do the same thing that we did for the specular roughness, right? So you can mix your original value of SSS, and you can mix that with a region of the face with the isolation masks and use a different value. In our case, it wasn't needed because, once you balance everything well, things should look good. But again, if you feel that in this render, I don't know, the ears have too much SSS, just multiply by a value the ISO mask of the ear, and it will look good, right? It's the same thing that I show you here. So, it's just a repetition, essentially, of the roughness setup, but for the SSS, right? So this is the scale that we're using. Again, if you want more or less, use a multiply with the same value, right? So let's do that. You connect this to the SSS scale, and you would get the same. And then you would mix this value with, let's say you want more SSS on the ears. So then you do, let's say, that, and in the mix, you connect, where are the ears? Here is the blue channel, right? You do that, and then you will get more SSS on the, you connect this one here, and then you will get this value on the ears, as simple as that. All right, and you can complicate this as much as possible, right, or as much as you want, but try to keep things as simple as possible. All right, that's my advice. Cool. So maybe in a future video, when it comes to digidoubles, we can talk about eyes setup, which is also a little bit complex, and grooming and other things. But for now, we're gonna keep it here. All right, good. So thanks for watching, and I will see you in the next video. Bye.